Hey everyone, this is 14.1, Organizing and Visualizing Data. We're going to talk about four main ways to visualize some data. That'll be frequency tables, bar graphs, histograms, and stem and leaf plots. We're going to start with some frequency tables. Here on page 710, number 1, it says construct a frequency table, a relative frequency table, and a bar graph for the data given. Pretty much anytime you want to create a bar graph or a histogram, you're going to need a frequency table first. So frequency table is the most basic way to organize your data. It just tells you what values show up in your data and how often they show up. So number 1, it says the number of hours of flight time for 20 amateur pilots last month were, and then you have these 20 lists of data. So the first one is 7. That means one of these amateur pilots logged in 7 hours of flight time for that month. So what I've done is kind of constructed this table for you already, and over in the hours, I have listed the different hours that you see. These are the different data values that show up. Right? We have 2s, 5s, 6s, 7s, 8s, 9s, and 10s. So if you actually go through the data and figure it out, that's what we have. I listed it in ascending order just because it's a little bit easier. That's probably the best way to do it. And now we're going to go through and count up the frequency. And for frequency, see how our first value is 2? If you look through the data, 2 only shows up once. So for the frequency, we're just going to put a 1. And that's our frequency for 2. That just means that one person logged in 2 hours. Now for 5, if we go through, there should be 1, 2, 3 5s. So that'll be a frequency of 3. And so on. Turns out we have 2 6s, 4 7s, 4 8s, 3 9s, and 3 10s. Right, that is a frequency table right there. It just shows you the values that you have in your data, the 2, 5, 6, 7, etc. And the frequency tells you how often those data values occurred in the data set. Down here at the total, sometimes this is useful for a variety of different calculations. It's also mostly useful to make sure that you didn't leave out a value or you didn't count too many. These should total to 20 because there were 20 data values, and indeed I think these do total to 20. So there you go, that's a frequency table. We're going to add onto this a relative frequency table, which is essentially the same thing, except you take the frequency and you divide it by how many there are. So instead of 1 here, we're going to have 1 over 20. And then we'll have 3 over 20, 2 over 20, 4 over 20, etc. Pretty much the same thing, except that it's easier to compare data sets. If you're comparing two data sets that have maybe different sizes of data, like this has 20 values, but say you're comparing 100 amateur pilots at the same time. So you have the set of 20 and a set of 100. Well, the set of 100 is going to look, your frequencies are going to be a lot larger just because you have more people. If you divide it by how many you have, though, it turns it into a ratio, essentially, and then it's easier to compare. So this is essentially a relative frequency table. I just want you to be aware that often they'll want you to write these as decimals. So this is 0.05. So I think the problems in the homework say write it as a decimal, round it to the nearest hundredth or something like that. It's not getting any better. So either way, that's frequency table and relative frequency table. So what we're going to do is we're going to use the frequency table to build a bar graph now. So our bar graph is essentially the same thing as our frequency table. It's just kind of laid out in a more visual representation. On the left we'll have our frequencies. Our frequencies, none were higher than 4, so I just put it up 1, 2, 3, 4, 5. And then at the bottom we have our classes, which are just the different values that showed up in our data set, our 2, 5, etc. And these are standing for hours of flight time down there. So all we're going to do is we're going to make a bar over the 2, and its height is going to be the frequency, the number of 2s we had. Well, if you look back at our frequency table, it said that we had 1, 2. So I'm just going to make a little bar with height 1 over the 2. And then for 5 we had 3, 5, so I'll make a bar with height 3 over the 5. Notice I'm not connecting these bars because these are basically separate pieces of data, separate classes that will have their own measurements. 6, there were two 6s. 7, there were 4. 8, there were 4. 9, there were 3. And 10, there were 3. Right, and that's it. That's a bar graph. We're essentially just taking our frequencies and plotting them in a bar, and you can see things like, what were the highest, what is the data trending towards. Here it seems a little bit heavier towards the higher numbers, simply because, which I think would make sense because if you're an amateur pilot, you want to log in lots of hours to get better at it. There's one person down there at the 2. I don't know if they really have the flying down or if they're slacking off a little bit, but that's kind of what you're getting anytime you organize data visually. So that is a bar graph. Alright, on page 711, we're going to do number 8, which says the following are scores on a 100-point language aptitude test given to 60 people who are applying for the Peace Corps. So these are test scores out of 100, and there are 60 of them. And here's your big set of data. It says use classes of width 10 starting at 40.5. So just like last time, these are your classes. When we were doing the bar graph, the classes were simply what showed up, right? What values did we actually see? When you're doing a histogram, your classes are usually going to be in a range like this, because histograms are different than bar graphs because they're going to have what we call continuous data, and the bars are going to be right next to each other. So they tell you exactly how to set up the classes. They say starting at 40.5, classes of width 10. So I went ahead and penciled these in. Starting at 40.5, if you add 10 to it, you get 50.5. And then 50.5 to 60.5, etc. See how the differences are 10? Now, where do you stop? It didn't tell us where, but all of our values are less than 100. So obviously I don't need a class past 100.5. The other thing you have to be careful about here is, see how we end at 50.5 and pick back up at 50.5? Well, luckily in our data, there are no 0.5s, so I know that we're not going to get a score of 50.5. But sometimes they will give you instructions where they say, use these classes, and they might say something like, if a value lies on the boundary, count it in the higher class, or count it in the lower class. So if you do have some ambiguity where your value is one of the endpoints, the problem should give you instructions about how to deal with that. So here we don't have to worry about that because all of our data is going to fall within these ranges. So we're just going to go through and count them all up. I've done this for you too, and I promise you it's pretty tedious. 40.5 to 50.5, there's only one value. I'll find it for you. It's right there, 41. Right, so there's only one value in the 40s. And then for the 50 to 60s, you're basically counting all in the 50s. Well, there is, let's see, there is 1, 2, 3, where's the other one? 4, right there. There are 4 values in the 50s, so I put a frequency of 4. Now, when you have a big data set like this, especially on a test or something, I recommend you go through and you actually check the numbers off as you use them. That way you don't count twice or count too few. You can also do that trick where if you add these frequencies here, they should all add up to, 60, because there are 60 people applying for the Peace Corps. So I double checked, they all add up to 60. Now notice this problem is not asking you for a frequency table at all. It's simply asking you for, I guess you don't even have the instructions there, but if you look at page 711, it is asking you for a histogram. That's what we're after here. Let me make sure that's clear. So the problem's asking us for a histogram. And anytime, like I said, if you want a histogram or a bar graph, you need a frequency table first to organize the data. And then the histogram or bar graph is essentially that frequency table in a graph form. So that's what we're going to do now. Alright, so I've laid this all out as our, I've laid this histogram out just like our frequency table back there. Our classes are down at the bottom from 40 to 50 to 60.5, etc. And our frequencies are on the left. Our highest frequency, what was it? It was 21, I think. That's why my data only goes up to 20. I guess I should technically put a little hash mark past that. There you go. I'm counting by 2s here, not for any good reason, just so that I don't have to draw 20 different marks, and so it's not too big or too wide. That's kind of subjective there, so you can make the scale however you want, as long as it's readable and you don't make any mistakes. So I decided to go by 2s, and I showed you the 4s. So it's 2, 4, 6, 8, 10, 12, etc. So we are going to draw a bar in for the height of we're going to match the frequencies to the height of the bars for these classes. And here, since this is a histogram, we're actually going to put the bars right next to each other without a space. So for our first one, the frequency was just 1. So that's going to be halfway between this first hash mark, which will be something like that. Right, so that's our first bar down at 1. Our second bar has a height of 4, so right next to this one we're going to go up to 4 and over. Our next bar has a height of 10, so that's between the 8 and the 12 over there. So about there. There's our 10. Then we have, I think it was 12, 14. So we'll go up to here. That has height of 14. And then we are between 80 and 90. That one has a height of 21, so that was our highest one. All the way up here. It's kind of hard for me to see, but it should be between the 20 and that next mark, which would be 22. So there's roughly 21. And then we're back down to 14 again, which is right about here. So there you go. There's a histogram, very similar to the bar graph. In fact, in the next slide, I'll talk about the differences. But remember, the whole point of this is just to take a big set of data and organize it in some meaningful way that kind of summarizes what's going on. Here you can see the highest. Most people scored between 80 and 90. And it's leaning towards the larger scores too. Very few people failed this outright, which is good. Actually, it was only one person, unfortunately, who got below a 50. And so you can kind of just see a spread of the data here. Alright, so bar graphs and histograms, like I said, they're very similar. They both are graphs involving bars, essentially. Bar graphs deal with what are called categorical data. Your data doesn't have to be numbers necessarily. It could be, you could be, counting up how many boxes you have or how many triangles you have. Down in my example down here, I put X, Y, and Z, right? It can just stand for any object, anything, and you're just measuring how many of X's you have, how many of Y's, how many of Z's. Okay, there is no scale down here. And obviously the bars have space between. If you're just looking at them, these are how you tell the difference. Bars with space between, probably a bar graph. No space between, probably a histogram. Histograms deal with what are called continuous data. Usually this just means numbers, but it's often when you're taking measurements of a lot of things. So if we were to take a measurement of the height of everyone in the class, we would probably set up a scale. An easy way might be 4 feet, 5 feet, 6 feet, 7 feet. How many people fit in those between those classes, essentially? And you might have some people on the ends. So like we said, you'd have to make up a rule for counting them in the higher or the lower. But either way, it's continuous data. You have a scale down here, and you're counting up the number of values that lie between these scales. Over here, these could just be categories, and you're just counting up how many of each category you had. So that's kind of the main difference between bar graphs and histograms. Alright, our last type of visual representation of data is called a stem and leaf plot. And here on page 711, number 10, that's what they want us to create, a stem and leaf plot. And you don't have to do this with two sets of data, but most commonly it's mostly useful in order to represent two sets of data next to each other so that you can kind of compare and contrast them. So I'm not going to do this whole thing because it could take a while, but let me just show you kind of basically how it goes. I've already set up the middle here. My X data set is going to be off to the right, my Y on the left, and in the middle I have 1, 2, 3, 4, 5 because these represent the powers of 10 that I have. Or sorry, the values in the tens place I have. So I have values like 16 up here, which are in the tens, right? I have values in the 20s like 22. Sorry, there you go, 22. 30s, 38, 40s, 42, 50s, 59. There are no values in the 60s, right? And there are no values in the single digits. So these are representing all of my tens. I've got 10s, 20s, 30s, 40s, 50s. So if I'm just looking at the X set first, let's look at our tens. We have 16, 18, and an 18. So what I'm going to write in the X column is a 6, an 8, and an 8. And again, what this represents is I have 1 in the 10s, 6 in the 1s. This is my 16. There's my 18, and a repetition, I have another 18. This is in ascending order, right? It should be ordered like this, and you should show your representations. So this is just a quick way to summarize 16, 18, and 18, which I have in my data. Let's go on to the 20s. For the 20s here, let me cheat a little bit. For the 20s, I have a 21. I have two 22s. I have a 24, 26, and a 29. So those are all the values in the 20s from my data set. And again, just a quick way to write them. They're in ascending order outwards, right? And you show the repetitions. And so obviously you can do the same thing for the 30s, 40s, and 50s, etc. Let me show you just the left-hand side a little bit so we can just get a good idea of what's going on here. For the Y set, for my 10s, I have a couple more. I have a 14, two 16s, a 17, and an 18. Those are all my Y values that are in the tens. For the 20s, I have a bunch as well, but I do want to show you some of them. I'm going to have to squish them in here. I have a 20, so it's 2 0, so I'm going to put a 0. So even for 20, you have to put a 0. I have 3 1s, 1, 1, 1. Sorry, 3 21s, that is, 21, 21, and 21. Then I have 3 22s, 22, 22, 22. And then a 23, 24. Yeah, I'm going to run out of room like I thought. 23, 24, 26. There's a 28 and a 9 over there somewhere. Sorry. Bad form. But you get the idea, right? You're just going through. Again, I would recommend crossing them off as you use them. And you're going to make sure it's in ascending order away from the middle column. Show your repetitions and show your 20s, right? Or your values on the dot. So put a 0 in there if you need. And you'll do the same thing for the 3, the 4, and the 5s. And so once you have this, you can compare these two data sets. So far I know that I have a lot of values in the 20s for my Y set and not nearly as many in my X set. I have a lot of values in the 10s over here and not as many over here, right? And maybe when you get to the 50s, you might be able to see something else. In fact, I think the X has the 59. Actually, no, they both have 59s, yeah. So either way, you have two sets of data back to back to each other. You don't have to write out each value. You're summarizing them by the powers of 10. And then you can compare the data sets because they're sitting right next to each other. And that's what a stem and leaf plot does. Alright, our last problem here on page 711. This problem just gives us a graph and it's going to ask us some questions about it. But it's actually a pretty challenging problem, even though it's not really going to require any math. It's going to require some careful understanding of what the graph does and what the questions are asking. So let's take a look. Number 13 here, it says, the manager at the local Starbucks counted the customers once each hour over a busy weekend. Summarize the results she obtained in the following bar graph. Okay, so she counted the customers once each hour over a busy weekend. So once each hour, she went out to the floor and she counted out how many people were in there, and then she recorded it. So that's what our graph is representing here. We have the number of customers down here, so 0 customers, 1, 2, 3, etc. And the heights of the bars are the frequencies, meaning how many times she counted that. So for example, there are 2 customers in Starbucks. It looks like a total of 5 different times. So 5 times she went out, like on the hour or whatever, to count how many people were there, and 5 different times she counted 2 customers. Notice 3 and 4, she never counted 3 customers or 4 customers because the height is 0 here. Same thing with 10 and 11. So part A says, what was the largest number of customers in the bar and how often did it occur? So what was the largest number of customers in the bar? This is kind of misleading because, or it's a little bit tricky because a lot of students are going to just go for the highest bar, right? But this is number of customers down here. The largest number of customers in the bar must be the largest number over here, which is 12. And the height of the bar, which is 2, represents the number of times she counted 12 people. So the largest number of customers in the bar is 12, and she counted it 2 different times. That's the answer to part A. For part B, what was the most frequently occurring non-zero customer count? Well, if you look at the heights of the bars, 0 is the most frequently occurring count. So 13 different times, so 13 different hours, she went out to count the number of customers, and there were 0 in there. But they're saying what's the most frequently occurring non-zero customer count. So if we ignore the 0, it looks like this is our highest bar. That would be 6. So she counted 6 customers 12 different times. So the most frequently occurring non-zero customer count would just be 6. That's the answer to part B. For part C, for how many hours were the customers counted? Well, remember, she counts every single hour, right? 12 here. She counted 12 customers 2 different times. That means there's 2 hours that she went out to count customers, and she came back with 12. Well, like right here, the height is 5. For 5 different hours she went out to count, she ended up getting 9. All we really need, though, for how many hours did she count, essentially, we're going to add up the heights of all the bars. So we have a 2, a 5, I said, a 6, etc. So take the heights of all these bars. These represent how many times she counted whatever she counted there. And we're just going to add up all those heights together. And if you do that, you should get 71. So for 71 different hours, she went out to count how many customers were in Starbucks. And then lastly, for what fractional part of the total number of hours were there more than 6 customers in the bar? for what fractional part of the total number of hours? Well, the total number of hours we just counted, it was 71, right? And when it says for what fractional part, they just basically want a fraction over 71. Now the part we have to figure out is for how many hours were there more than 6 customers in the bar? So here's 6. We want more than it though. So how many times were there 7, 8, 9, 10, 11, and 12? Well, there weren't 10 or 11, but we can count up how many 7s there were. There were 9 of them. How many 8 counts? There were 6. How many 9 counts? There were 5, etc. So add up that 9, 6, 5, and 2. You should get 22. So the fraction part will be 22 out of 71. There were 22 times that she counted more than 6 people in the bar out of the total 71 times she counted overall. So that's the answer, 22 over 71. So like I said, it's notice I didn't really have to do any math. Yeah, we had to add up some numbers here and make a fraction, but this is really about understanding what the graph is showing you and understanding very specifically what the questions are asking you. So that's it for 14.1. Let me know if you have any questions and keep up the good work.